Like to welcome everybody to the October edition of Tennessee Turf Tuesdays. This is our final Turf Tuesdays for 2021. It's been fun to have this series be a part of the 2021 year, and I can tell you on behalf of the entire turf team at UT, this will be back in 2022. You may see a survey come out from us about maybe potential changes and adjustments for the 2022 series. We've got some ideas in mind on how to get this Turf Tuesday series to you on a diversity of different platforms, and it is here to stay. So you will be able to participate next year to get all the pesticide credits that you need to stay certified. On that note, I should say, for those of you who have registered for today, I know pesticide credits are important. All of your information about pesticide certification was captured at registration. So if you are looking for Tennessee pesticide credits, for example, I know many with us this morning are, all of your information was captured at registration. You don't need to do anything further. And that is going to be the case for almost every other state that we've been awarded credits for. The only outlier to that is New Jersey. So if you are with us and you are needing pesticide credits for New Jersey, please send me a photo, a time-stamped photo with your government ID at the beginning and at the end of the webinar. That is one other level that New Jersey requires for pesticide certification in their state. To get your credits, stay with us for the duration of the hour. Zoom will monitor all that stuff, and we use the Zoom roster in order to have a list of everybody who was with us for the hour so you can earn the credit that you need. This webinar is being recorded, so if you are watching this on YouTube after the event, there are no pesticide credits for the recorded version. You need to stay with us live for the entirety of the session. We'll do GCSAA credentials at the end. I'll give you the code that you need for the Golf Course Superintendents Association of America continuing ed piece that many of you golf course superintendents desire. Before we jump into the kind of nuts and bolts of what we want to talk about today with shoulder season foes, particularly for warm season turf, if you have questions as we go through this, please use the Q&A box at the bottom of your screen. That helps us keep track of the questions as they come in. It also keeps the questions and the answers threaded. So if there are questions that we can't answer on the live broadcast, we'll type those into that box and it'll keep everything neat and tidy. So if you have questions, please use the Q&A box. I think that kind of covers all of the nuts and bolts in terms of logistical parameters. I'd like to welcome my colleague, Dr. Brandon Horvath, to the session. How are you, Brandon?
Good, Jim.
We've got a fun topic today. I don't know about the disease world, but for what I do with weed control, you know, many view this as the end of the year. This is kind of the beginning of the year, right, for us. And I know it's probably the same is true with disease, because if you have spring dead spot or large patch issues, or you make poor decisions, let's say, about spring dead spot or large patch, that's probably going to put a hitch in your giddy up going into 2022. Is that right?
Yeah, absolutely. I mean, that's the challenge with the warm season diseases, right? Is that this time of year that plant is slowing down. It's starting to get ready for dormancy. It's starting to kind of get itself shut down for the winter. And if you have a problem with one of these diseases right now, you're probably going to look at it at least through the spring. And as we've seen with some examples of some of the zoysias, you might be looking at it all summer. So, it's one of those things that if you're going to explore some of these grasses that are out there, you want to have a good handle on what the problems are and when these applications need to be made, so that you're not caught in a situation where you're struggling to recover from damage that was preventable, almost, 6 months or 8 months prior.
Yeah, and I think the same's true in the weed control world. Historically, POA has been something that no one really thinks about until January or February when they can see it. But as we have had more issues with POA, I think the balance has shifted to being proactive in the fall to set up for a good start to the spring. I'm going to share my screen really quick and bring up a slide. I'm going to start here. So, this question about POA emergence, I remember when I started at UT, people would talk about, well, you got to get your pre-POA out before Labor Day. And I never really questioned where that came from or why. It was just, that's what everybody talked about and what everybody did. And one of the things that's been learned over time is that we don't have as much precision if you want to control POA pre as we would with, say, pre-crabgrass in the spring. Think about crabgrass. I'm sure, Brandon, you learned in school, just like I did, 55 Fahrenheit soil temperature for 2 or 3 consecutive days, and you get crabgrass germination.
When the forsythia blooms.
Right. And we just don't have that with POA, which begs all these questions. So
is that largely because, it's the window of time that emergence is happening? Like it's just crabgrass germinates like all in kind of a pretty set window, pretty tight, and POA is much broader because you certainly have a flush, but then there's a bunch of other individuals that are germinating on either side of that.
I think that's right. And I'd make a case, albeit with not maybe all the data I would need to make this case. There's more environmental adaptability maybe in POA than there is with crabgrass. So you just have windows of opportunity. Like you said, it's a wider span of time for which you can do that, where I don't know that crabgrass, be it smooth crabgrass or large crabgrass, has that same environmental adaptability where it can come in maybe conditions that are as widespread as POA would.
Sure.
Brandon, you're familiar with the slide on the screen. So Brandon and I were advisors for a graduate student here a few years ago, Dallas Taylor, and her master's project kind of got at this question, looking at POA emergence in Bermuda grass. And her goal was to try to develop a model to predict not only when emergence would happen, but different percentages of emergence throughout a year, so you could kind of know where you were along that curve. And I've talked about this with several audiences that, to do this, it was fairly labor intensive, probably building my reputation as a hard advisor, I guess. She had replicated plots at the research farm, and I don't think it was 52 weeks in a row in a year, but it was every single week from January to the 1st of May. And then I think from May to September 1st, it was every other week. And then from September 1st through the end of the year, it was every single week. So almost 52 total weeks of going out to her plots with tweezers and scouting for POA seedlings. If a POA seedling was there, she would remove it with the tweezers and record its presence. Doing that, she had this really robust data set where she could see for the duration of 2019, which is on this side of the screen, when her POA emergence happened. And she worked with some climate data scientists to develop a model to fit that pattern. In 2019, obviously, she did this after she had the data that it fit pretty well. Fast forward a little bit to 2020, and the question changed a little in that it was now, well, let's see how accurate that model is in predicting what will actually happen. And what we learned was it wasn't very accurate. It really under-predicted emergence, not only when it started to happen, but the duration for which it happened in 2020. And she got pretty disappointed about the fact that it didn't work. And, Brandon and I talked to her that, well, when turfgrass managers were reaching out about POA questions, they really weren't asking, well, what percent emergence are we? Are we at 25% emergence or 30% emergence? You know, they just wanted to know when they could go out and pull their trigger on making an application. And with that in mind, you know, this has become kind of a key for at least what we do in my research program now, that we think applications need to be made when emergence is most rapidly changing. When we go from we don't have POA to now it's coming and it's emerging and we have more and more every single day. So Dallas looked into her data, and if you look at these two curves, one for 2019 and one for 2020, emergence is most rapidly changing when the green line is the steepest, right? When we go from not a lot of plants to a lot of plants, and we do it very quickly. In the environmental conditions, when that happened, were consistent year over year, not only at our research farm, but at 2 other golf course locations in and around Knoxville. And this kind of is the summation of her whole work. That so what we learned from that 2-year project was that POA emergence most rapidly changed when our weekly soil temperature at a 2-inch depth was less than 70 Fahrenheit, and we had some rainfall. So in her study, a ½ an inch of rainfall within a preceding 7-day period, that was the trigger for kind of when POA started. So what we've done, and I think this can be helpful for many of you, is you can use this as a guide. That so if you want to use a true pre for POA, so you want to make a barricade application or a pendulum application or a dimension application pre, you want to be as close to that 70 Fahrenheit benchmark without going under, right? So, you know, a perfect application might be that your average soil temperature is 71. Now you've positioned that pre as close to the trigger temperature as you can without emergence already starting.
Hey, Jim.
Yeah, go ahead, Brandon.
Can you go back to the previous slide? I just noticed something that I hadn't noticed before, or there you go.
Okay.
So like, even though the model in 2020 doesn't do a very good job of predicting the total actual emergence, right? Mm-hmm. It does do a really good job of capturing that initial burst as things are starting to happen down at the bottom. And if the other thing that I see is from an end user perspective, those are at 2 different times. Like, even though, and that goes back. So then if you go back to the slide that you were showing just a second ago, that really captures this idea that you want to get that pre out right before emergence happens and use that as a trigger to trigger that application, rather than just going, I'm going to go mid-September every year, or I'm going to get it out just after Labor Day or whatever. Cause that could be 6 weeks too early in some cases. And that could be right on the money in some cases, depending on the year. And now we've got a pretty good idea of what that window is where you want to get that application out. Right.
Right. No, that's exactly right. And I mean, and I can tell you, embarrassingly, you know, in my career here, we have put pre-POA treatments out as early as the last week of August. And I think what we've learned is that is ridiculously too early for much of the state. This year,
and the mindset goes back, like you made the analogy back to crab, right? That a lot of northern states, like there's some places that'll put crab out like in, November, just before the snow flies. And it'll prevent that early flush of crab germination in the spring, because it just sits there and it doesn't really degrade because there's not a lot of rainfall moving through and whatever. And so you might lose a little bit of activity with some thaw from snow, but like you're not, but here that doesn't work all that well. That really early app with the amount of rainfall that we tend to get in fairly timely rains, it's not going to last as long as you might like it to.
Well, and these pre-herbicides are microbially degraded in soil. So you start thinking about,
soil temperatures are warmer.
Yeah, I go make an application the last week of August and my soil temperature is 83 and it's full sunlight and I get 2 or 3 afternoon thunder showers. That is a perfect recipe for that herbicide degrading and then not being there in a concentration that you would want it to be when
Yeah.
you get to this key temperature, right? I look at it as it's like I think there's plenty of crabgrass applications that go out way too early, even in this climate, because they're often tank mixed with non-selectives in the
Sure.
Bermuda grass world. So,
And then you also have, so then on top of that, you could also weave in the challenge or the potential that we see with the emergence of these herbicide resistant individuals, right? Because if you're putting this, historically, if we've put this pre out way too early, we get microbial degradation, water, rain, et cetera, getting the concentration of that herbicide down to a low enough level where it becomes sublethal. That's the recipe for resistance.
right. And it's a recipe for what's called non-target site resistance, which we can get into if we have time. I want to get into disease stuff too, but
Sure.
that's when we can have plants that survive unrelated modes of action, and it gets really, really scary, really fast. So, I think for now, like we put our pre-emergence herbicide applications for POA out 2 weeks ago. Many of you that are listening with us this morning in East Tennessee, we had a front go through, and we had our soil temperatures drop. We had 2 or 3 days of rainfall in a row, and we got into a place of 72 average soil temperature, and we're really well-timed pre's. The take-home message is that's probably later than many of you have historically put a pre-POA treatment out. And then I think now we're into this window where we're kind of into this piece. We've had a little bit of an uptick in soil temperature since that drop, but we're forecasted to go back down again. So, if you're going to be one to use a pre-post mixture, which there's a lot of good reasons to do, I would say that the window to do that is open. And if we have time later on, we can talk about some really good pre-post mixture treatments. I know that there's interest in that throughout the turfgrass industry. We got a question here. What about late germination? We see a lot of breakthrough in late March. When are we safe from POA germination in the spring? So I am really glad that you asked that question.
And just to point out, just make sure that if you do have a question, put it into the Q&A box. It makes it easier for us versus the chat box. It's a little challenging sometimes when they come in through the chat. So
I'm going to skip a couple slides here and go to this. This is a photo from one of our field sites from last year, where we evaluate a lot of herbicide mixtures, different POA control strategies. And there's a lot of really good plots here, right? Where we've done a really good job controlling POA. But as was noted in the question, you see lots of breakthrough. You go to golf course sites or sports field sites in the spring, and you see tons of breakthrough, and we don't see that in our plots. So this begs all these questions, and we just had one. Why does this happen? Well, there's a case to be made that it's spring germination, but I'm not so sure about that, because at least in my experience, when these breakthrough cases happen, these are really large plants, multi-tiller, large plants, often with seed heads. I don't think this is something that has germinated in February or March when there's a window to do that. And we have a student here at UT who has been working on this topic. And what we have learned is that, we have some assumptions in what we do with POA control that might be a little flawed. And yes, I think that assumption, is that all the POA that we control is from annual germination events. And I don't know that that's right. I think it's more likely when we think about a POA population on a golf course, it's going to be a combination of annual germination, yearly emergence of new seedlings, and it's going to be some plants that survive perennially. And that's going to change depending on where you are. If Brandon, you went to school in Michigan, right?
Yep.
POA lives all year there
All year.
with seed heads, bunch type growth, all different heights of cut. POA is just part of the deal.
And it doesn't die in the heat.
And it doesn't die in the heat. And I'm sure if you opened up a site, you had a void in the turf canopy, you remove turf cover, you're probably going to get POA seedlings that come in, right?
Yep.
Right.
Absolutely.
So the percentage there, it's going to be a high percentage of year over year survival and a low percentage of new seedlings. Well, what we're learning is that the South, the transition zone, in particular the Southern US, it's probably the same thing, but reverse percentages, that most of what we control is new seedlings, but there's going to be a small cohort that is year over year survival. And for me, when we're spraying 25 square foot research plots, our likelihood of seeing year over year survival plants is pretty low. We're really only targeting the new seedlings, right? And that's why our well-timed herbicide mixtures in autumn look so good. But there's going to be areas where we have plants that survive perennially, and that's going to need some sort of follow-up application in the spring. A lot of those may be plants that are, let's call it, dormant from summer, that haven't fully come out of a dormancy period when we start to make our treatments in the fall of the year. I know, Brandon, you'll like this. So here we talk about POA as an annual plant, and that's discussed in Turfgrass at length. And you start to read plant physiology books and get definitions of annual plants, and all of a sudden POA doesn't look like an annual anymore.
Well, and we do a disservice to the assumption part of that with some of our common names, right? Annual bluegrass, perennial ryegrass. Well, yep. We all know down in the deep South, if you overseed perennial ryegrass in the fall, that through the summer, most of it's going to die. Some of it's going to hang around, and you're going to get some germination of seed that you put down the previous year, but it's perennial ryegrass. Well, it's a perennial grass, period. And I would argue that annual ryegrass is probably pretty similar.
Right. And, the definition of an annual is when you have abrupt senescence, even when growing conditions are optimal, right? It doesn't matter where we plant corn. Eventually, it's going to get to the point that you see on the screen, no matter what the growing conditions are. Well, that's not true with POA, right? We can have POA that is going to just keep on growing, even when growing conditions are optimal. And there's all sorts of golf courses that are out there that are all
there's a few. Those are just a couple
high-end places that are pretty heavy POA, that if this was an annual plant that went into senescence when it was done living its life cycle, they wouldn't have much of a membership anymore. This is just a quick timeline that my grad student Devin Carroll put together. So as part of her PhD project, she went over to the UT library and she met with the librarians, and she said, I want you to take me through the scientific literature from the first report of POA annua as a species in 1753 by Linnaeus to present day. And to her credit, she got all those papers and she read all those papers. She had to have many of them translated from German into English. And she learned a lot from doing that. And probably the biggest thing that she learned is that there's almost no information to justify why we consider POA annua to be an annual species, other than the inference of the name annua. And I think, Brandon, you asked her in her comprehensive exams, why, we don't know, because none of us were alive in 1753. Why do you think Linnaeus named it annua? And I think her answer was, well, maybe it's because it had a lot of seed heads when it was first reported. And that would give the inference of an annual plant. But you and I both know there's plenty of perennials that set a lot of seed.
Yeah. And I think the other thing that she discovered in doing this is that a lot of our colleagues over the last 35 or 40 years have not done the translation and reading of the full paper, because there's a lot of instances in the literature where some of the information that she's discovered from things like House Connect or Beck, that these German papers, don't provide a whole lot of evidence. For example, like the var reptans thing, right? Like learning that var reptans means, repto from creeping or spreading, that is not perennial at all. That's a plant that's low growing and creeping along the ground.
And the thing is, for those listening, this is a fun academic discussion, but I kind of think that those that manage turfgrass for a living already know this and have figured it out. I'm just going to show a series of photos that have been sent to me from turfgrass managers across Tennessee. This is one from last October. That's not a plant that germinated in the fall of 2020 to be that big on October 1st. That is a plant that survived. Here's a text message from another superintendent in Tennessee talking about wanting to know what the emergence model looked like and saying that all he sees is tiller plants that have survived the summer. Here's a photo from a golf course in Nashville. It's from 2019. That's a zoysia grass fairway. And again, those are not newly germinated POA seedlings. Those are plants that have survived the summer in Nashville. Here's POA annua in our research green. I took this photo this year on July 6th, and that POA is doing just fine, surviving the summer in East Tennessee. Here's some POA Brandon and I found on a trip out to Memphis in June in latitude 36, and it's just doing fine. That I think one of the things that hurts us as a discipline is we've all gone through school and we've read these textbooks about POA as an annual, and well, it's a winter annual. And well, when we live in the Southeast, you wouldn't even think to look for it, right? Because you went through school learning that this was a winter annual species. And this has become one of those situations that the more that we look for this, the more that we find. And, I think a pretty good segue into the latter half of today's Turf Tuesday is to talk about disease. My student Devin has done a lot of work to figure out, well, what actually kills POA in this region. And, we don't have enough time to go through all the details, but not surprisingly, it's not heat, it's not drought, it's actually disease, right? And in my world, Brandon, summer decline of POA annua isn't really recognized, but in your world, this is kind of a well-established and well-understood thing, right?
Yeah, I mean, to challenge or to channel my former PhD advisor, I would argue that it's not cooler on the left side of that picture versus the right side of the picture versus the center of the picture. The difference is that you're spraying fungicides on those two left and right in the middle of that huge heat wave that they had up in the Pacific Northwest this summer, where they had monstrously hot temperatures. And the thing is that, this grass in the middle that wasn't treated with fungicides, that happens to be annual bluegrass, is dying, and it's dying because of disease pressure, not because of fungicide or because of heat. It's dying because of the fact that you haven't sprayed fungicides to manage it to survive. Well, and that raises some really interesting management questions that you and I have just begun to embark on, I think.
Right. And, I think it's an important point for those listening is that the pathogens that can affect turf grasses, they're kind of ubiquitous, right? And it's just a matter of having the right environmental conditions for them to produce symptoms. I mean, Brandon, you went out with Devin, was it 2 weeks ago, and found anthracnose on POA annua in a golf course in Knoxville? I mean, we're not in anthracnose weather at all. But nope. If you go look for it, you can find it.
Oh, you most certainly can.
So, what this all means for you listening as we kind of segue out of the weed science portion and talk a little bit about winter diseases is that, again, we're going to make applications this fall, and that by and large, those are going to target new seedlings. But you're going to have some plants that survive perennially, and they're going to need a different strategy because they may not be there to absorb, if you're using a mixture of spectacle, tribute, and simazine, well, you might have pockets of your facility that don't have those plants up and emerged in order to be affected by that treatment. And I think that's a lot of what we see with spring breakthrough. So, look at areas where you might have low anthracnose pressure, more POA survival. Here's a real classic one from a golf course setting where that green, that's sprayed with fungicide all summer long. And you can see from the spray pattern into the collar, the product that hits the green also hits the collar. Well, those fungicides that are sprayed on that green to help it go through the summer disease-free are also going to help any POA that's in that collar continue to survive the summer. So then when we go into winter dormancy, you see an awful lot of POA in the collar that is going to be a little tricky to control. So it's there's a reason it's the most interesting weed in the world. Do you have a question, Dr. Horvath?
I do. So, Dr. Brosnan, could you wax poetic on what you think the trends of having more, as we're going to talk about here in a moment, having more fungicides to control things like spring dead spot and large batch might have on protecting and keeping our POA annua healthy and happy?
I have to think that we were in a world where we had one fungicide to target some of these winter diseases in Rubigan, and it just so happened to be pretty injurious to POA to the extent it's used in some scenarios for POA control. And now that that's no longer, part of the lexicon, no pun intended, we've got a whole nother suite of products, and they're not so injurious to POA. They help POA. So now as we treat some of these different unique stands of turf on golf courses, it's just going to help that POA continue to live and be a problem for those trying to eradicate it. I'm going to give you the baton. You run, my friend. You take it from here.
Yeah, well, that's very interesting. And if I can share my screen, I'll just put up a slide. I've got a couple of slides we can just kind of go through and talk about. This goes back to what you were just saying, right? That it's important to think about, and whenever I give this talk, I always ask the audience, like, what is this? And somebody always says it's the disease triangle because I'm a pathologist, but it's just a triangle, right? Until you put the line or the labels on it, it's just simply a triangle. But if we think about the typical, illustration of the disease triangle, always puts the labels at the vertices of the triangle. So you've got the host, the pathogen, and the environment. And it does a disservice to understanding the idea of the triangle and how it kind of conceptually works, right? You can think of this shaded area inside the triangle is the area of that triangle is the overall potential for disease, right? Doesn't guarantee disease is going to occur, and it doesn't say that you're going to have a lot of disease. What it says is that triangle gets larger, the area of that triangle, there's more potential for disease to occur. So if we conceptualize that to a management perspective, if we have a really suitable environment, then that side of the triangle might be pretty long. And if we have a really virulent pathogen, say, for example, like something like Pythium, that side's going to be pretty long. And if we have a really susceptible host, say, for example, something like annual bluegrass with anthracnose, that side's going to be pretty long. And so we have an area of the triangle that's going to be relatively large. Then any management practice that we employ that changes the sides of those edges of the triangle is going to shrink or reduce the area of that triangle, right? So in this example, let's say we we have a change in the environment, then that reduces the potential for disease. Fungicides kind of act on the area of the triangle. Most fungicides, when they're applied at an appropriate time for the pathogen to be active, are going to give us somewhere in the ballpark of 90% to 95% disease control. So if we were to take this triangle and shade out all but 5%, and then this triangle and shade out all but 5%, the 5% that's left over in both of those two triangles, the larger amount of disease is going to be in the previous slide, right? Make sense?
Yep.
So if that leftover disease is reduced, then we might not even see something like a perennial plant or what have you that's hanging around. But if all of a sudden we're making applications that dramatically change the ability of those plants to survive a potential pathogen outbreak, along with all the other things that they're trying to survive from an environmental perspective, then you're going to have plants that are sticking around, right? And that to me really conceptualizes this, and we didn't touch on it a whole lot, and you can maybe speak to it a little bit. But the other thing about that emergence timing is that it's awfully similar to these other pathogens that tend to be active in this fall period of time, right? It was what, 70 degrees, right?
Sub 70 with some moisture, which I think is like the target for spring dead spot, and maybe even the target for large patch too, right?
Yeah. So like large patch, our trigger is going to be right around 70 degrees, 65 to 70, 2-inch depth for 4 or 5, consecutive days. You need some consistency in temperature to get the pathogens active. Same thing with spring dead spot. Our trigger is usually right around 65. And we're going to pull that trigger to make those apps. And so that's, right now for us, it's go time right now for us as well. So you guys just put your apps out 2 weeks ago. We've put apps out last week and this week, and we'll be making probably another app or two on some of our trials this next following week. And then we'll be repeating in a month. And that's largely because at the rates that we're putting these things out, we're going to get about a 28-day window of control, and we're going to need another 28 days to get us to a point where the soil temperatures are cool enough that the pathogens aren't going to be all that active.
Well, and I think that's an important point, and it's kind of nuanced. And just for those that are listening that might not be familiar with this, I know for me, one of the things that I've learned over time is that it's easy to think that fungicides act like herbicides, in that herbicides kill weeds. So then the next logical jump would be, well, fungicides kill fungus. But that's not true, right?
No.
The fungicide, as I understand it, as a guy who just toils around with POA all day long, it allows the turf to grow out of the symptoms. So it kind of changes the environment in a way, right?
Right. It really arguably they're more properly called fungustats. So they stop the growth of the fungus for some period of time or slow it down to the point where it's not as able to infect, or if it's already infected the plant can grow fast enough and recover that you don't see symptom development. So the pathogen may still be there. It's just restricted in growing and restricted in doing the things that it does to produce things like the compounds that then cause the tissue to turn brown and whatever. So you don't see the symptom development, but it's still there, right? And if you put that product down, there's not like there's a bullhorn as the droplet comes out of the nozzle saying, "I'm only here for the desirable grass." Like, if there's an undesirable grass or an undesirable plant that you're spraying over, you're protecting it with fungicide too. And so any pathogen that might, take it out in the course of doing its business is going to, if that fungicide is active on that pathogen, it's not going to allow that pathogen to do that job. And I think one of the other things that's true here, and I'll just go to another slide here to just kind of showcase this, is if we look at And I guess maybe I can go. Okay, so.
Well, and as you look for that, I think
Okay, there we go.
going back to your spring dead spot, comment about spring dead spot timing. So, you think about you've started to make applications for spring dead spot control now, and then you need to come back in, 30 days or so and make another one. And that, as I understand it, is because that application that you've just made, it's not going to suppress the growth or stop the growth of that spring dead spot pathogen for the duration of time where the environment is favorable for it to be active, right? Because eventually the soil temperature is going to get so cold, it's not going to be active anymore. And you've got to get to that point. So you need 2 shots of that fungicide to get to a point where now that pathogen isn't going to be active and working on turf. Is that right?
Yeah, exactly. I mean, that's exactly it, is that you need this window of control, and you need to get to the point where the pathogen isn't active. Yeah. And
Wow.
and this kind of shows the challenges associated with the with the situation that we find ourselves with the fungicides that we have available to us. So if you look over time, so this was pulled from a couple of sites. We'll look at these sites in just a second. But the PPA1 document that's produced out of the University of Kentucky with some co-authors, and then the NC State's turf files document, pest control for turfgrass managers, that Dr. Kearns produces out of NC State. If you look at what has happened over the last 12 years, we've gone from 14 unique modes of action to 20. So that's great. We've got 6 more modes of action. We've seen an increase in the number of active ingredients within those 20 modes of action from 29 to 49. So we've got 20 more active ingredients. But then the other thing that you see is in terms of combating fungicide resistance and trying to, pre-mix fungicides so that they cover a broader spectrum of things. We've gone from 45 to 82 unique AI combinations that are available. The challenge is, and I think I've got it, and I just realized that with my new machine, I can just switch to another slide. That's pretty awesome. Is that the groups 3, 7, and 11, those are our 3 big mode of action groups, the DMI, QOI, and SDHI. The 3, 7, 11 make up a large majority of these groups. So in terms of the modes of action, we have 20 modes of action. Well, those 3 groups make up 15% of those modes of action that are available to you. But in terms of the active ingredients, 21 active ingredients are in those 3 groups. So that's almost half of the active ingredients that you have available are in those 3 groups. And of those unique AI combinations, you have out of the 82, there's 46 in those 3 groups, which means that there's 75% of those AI combinations have at least one of or 2 of those groups. So there's 3s and 7s, there's 7 and 11s. But if you look at that number, you realize that 75% of those combinations are going to have one of those 3 groups. So if you're making fungicide applications with 3s, 7, and 11, you're running into situations very, very quickly where you're raising the potential for resistance to those 3 groups. Now, with things like large patch and spring dead spot, we're fortunate that we don't need to worry as much because of the pathogen biology. We don't need to worry as much about those particular pathogens developing resistance. But we do need to be concerned about things like anthracnose. And if we're making lots of applications of these protectants on, say, a warm season surface in the late summer, early fall into the later fall, and we're applying that in a situation where anthracnose could be active, we could potentially be making anthracnose resistant, and that might help us with POA. honestly, because if the anthracnose is resistant to the fungicides, then it's not going to protect the POA. But the downside to that is you can get that anthracnose on your bent grass if you have a bent grass putting surface, and that's going to present challenges for you controlling it there as well. So it's important to recognize, I think, Jim, you pointed this out, that this isn't a like a box or a chimney, like, okay, just diseases or just weeds and herbicides. There's a lot of interconnection across both of these areas in terms of the things that we need to think about from a management perspective.
For sure. Can you go back one slide to your timeline of modes of action for 08? I think it was 08, 12, and 20.
Yeah.
Because it's interesting, I look at that and go, in a herbicide conversation, you're +6 from 08 to 20 in terms of new modes of action. Herbicide wise in turf would probably be up 2. Spectacle would be a new entry, and PoaCure would be a new entry. AI wise, I'd say would be up 2. And then unique AI combinations, I think, would be relatively flat. And that's one of the things that has just started to happen, is you're not seeing so many pre-packaged AI combinations, but it's more end users kind of being tasked with, okay, now we're going to go make our own unique AI combination and put Barricade with Monument and Simazine in a 3-way mixture to go out and treat. It's just interesting, the growth that's been there on the fungicide side, and we've been somewhat flat on the herbicide piece. And I don't know how much of that gets into herbicide tolerant cropping systems, because a lot of our new AIs come from row crop agriculture, and
that's the same for us.
The route of entry is just, it's a steep hill to get a new AI for anything, and it's a little bit easier to get a new trait for an older.
Yeah, for sure. That's something that's true for us as well, is that, when I don't, do you know what the gross approximate number is for bringing a new product to market for a herbicide?
I want to say it pushes 300 million, like it's in the high 2s. I know I've seen that presented somewhere, but lots happened since then.
Yeah. I mean, fungicides the same way. We're at, it's about 325 to 350 million. And so, anybody in the turf world is kidding themselves if they think that there's going to be a fungicide that's developed solely for the turf market, because we're not big enough to justify it. It's going to be for large crop agriculture, and then it's going to filter down to us. And that's largely where these modes of action have come from, is from, modes of action that were useful in cropping systems that they need a new use or whatever, so that it's some patent protection and things like that to then get a new use and continue to make money off the product or what have you. But yeah, it's very similar situation in fungicides.
So this is like a tangent, but let's go there because it's just fun to talk about these things. So, our conversation today has been really about the warm season grasses and kind of the interplay between maybe herbicides and fungicides, and certain fungicides setting up scenarios where it's harder for the herbicides to do what we want them to do. Knowing that we have a lot of extension folks that join us for these sessions, lawn care people as well. Tall fescue is a pretty popular lawn grass in our state, and it's often treated with fungicides in the summer. Is there a world out there where, say, summer fungicide applications on a tall fescue lawn might help POA continue to be a problem within that tall fescue lawn?
Absolutely. Our number one mode of action that we're going to use on brown patch is going to be the QOIs, right? And this is full credit to Kyle Miller from BASF, but the way to remember those 3 modes of action, the 3, 7, and 11 is NASCAR with Dale Earnhardt, and then 7-Eleven convenience stores. And the QOIs are the 11s, and that's going to be your number one go-to for brown patch control in tall fescue. And if you're looking at like a tall fescue Kentucky bluegrass mixture, you're going to use a QOI and a DMI to get dollar spot as well as brown patch. And so both of those are going to be effective against something like anthracnose that might be hanging around to kill POA, along with brown patch and dollar spot. And so you're protecting all of the plants that are growing in that lawn, not just the plant that you want to keep around. Like I said, there's not a bullhorn on the droplet as it comes out, letting it know, letting all the undesirable plants know that that droplet isn't there to protect them. It's only there to protect the desirable plant. It's whatever it hits. And if you're hitting a patch of POA, you're going to keep it alive.
I think in a POA control context, then, you could remember it as Michael Jordan, right? Because the ALS inhibitors are going to be group 2, and then the mitotic inhibitors are group 3. And that's the biggest chunk of our POA chemistry. I mean, there's nuances with, the photosystem 2 inhibitors like simazine will be group 5, and I think Ronstar's 14, but the biggest chunk of it might be that Michael Jordan piece of 2-3. So that's a fun way to remember it.
Yeah, exactly. I mean, it's just an easy way to remember the modes of action that you got to be concerned about. And I think the other thing too with large patches, and I'll just reference this little bit of data here from my PhD student, Jesse Benelli, but he was able to show pretty clearly that the severity of large patch gets dramatically worse whenever you're not getting the fungicide down into the basal part of the plant, which is where the pathogen resides. And so if you're, just getting it onto the leaf tissue, then you can expect, a significant amount of disease pressure. Whereas if you're getting it down into the sheath or the stem, you're able to reduce that disease. And that was true in both runs of his experiment, where getting it down into the sheath and stem portion of the plant, it was much more effective at controlling the disease. And this just kind of shows it, right? You get it down into the stem, you get the fungicide onto the sheath, the plants are alive, you keep it up on the leaf, and you've got the pathogen down below. You're in real trouble in terms of keeping the plant alive. And this is about as perfect a situation as you're going to get, right? This is in a controlled environment with inoculum, a high amount of inoculum. You can see multiple grains of inoculum there. And it's in a moist chamber being maintained at perfect conditions for disease development. I mean, we're trying to kill these plants quickly. And if that fungicide is where it needs to be, it protects it. And if it's not, it's dead. And what this tells us is that anytime we see breakthrough out in the field with fungicides for large patch control, it's often a situation where that material didn't get down into the basal part of the plant. So there's a couple of ways we can do that. One is that we can lightly irrigate an application into the canopy. If we're applying to something like zoysia grass, just a quick light application of irrigation, something in the 1/10 of an inch range, doesn't need to be a massive amount of water, just to get it off the leaf surface and down into that bottom part. The other thing that we've spent some time looking at are some of the Organo silicone surfactants. These are called super spreaders, and they're so good at dropping the surface tension of the droplet that they can actually make water go inside of a stomate on the plant, which is pretty hard to do. There's actually a paper out there from way back from Dr. Penner at Michigan State looking at is dithiopyr, is that dimension?
That's correct.
And that's typically a pre-emergent, right? Or a post-emergent.
And on crabgrass, it can go later onto like non-tillered crabgrass plants, and then you can get some control. I know they've tried to push the envelope on how late you can go, and it's a little bit foggy about how late's too late.
Yeah, right. And that's the paper I'm thinking of, is that they use this organosilicone to get the dithiopyr to go all the way down into the whorls of the plant. Wow. Down at the basal part of the plant to kill the crown. And we're a lot more successful at killing it in that situation than if they were just applying it with water or water volume or other like non-ionic surfactants or, MSO or whatever. And we saw the same thing with large patch control with these organosilicones, that if you get that droplet down into the basal part of the plant, then you're going to be much more successful at getting control of the disease. And so those are some of the things that you can think about with large patch control. And then I just want to kind of touch on too, I'll go over here and share. Where did you go? There you are. Just these couple of references. So the turf file site from NC State is excellent. You just go to the diseases, you get a drop down, and you can choose, like large patch. You get your description of symptoms, development factors, soil temperatures decline to 70 in the fall. It sounds eerily familiar from what we were talking about earlier. We get into this period, and then, a lot of cultural control recommendations. And then the thing that I really like about this site is it gives you some efficacy rating of how these materials work, and how well they're going to work under a reasonable amount of disease pressure. And his scale, I think, is pretty nice in that it's based on disease pressure. And I'll contrast that with the other site here in a second, or the other document. So you get good control when disease pressure is low is 1+, and 4+ is excellent when conditions are highly favorable. So you're looking for 3s and 4s if you can, in terms of disease control. It's not to say that a 1 or a 2 isn't going to work. It's just not going to work as well if you have really conducive conditions, and you might get some breakthrough and things like that. So, there's a lot of 4s going through here. Some of our newer products, things like Acernity, Pedigree, which is new. We've seen some really good activity with Tekken. Kalita is another one that we've seen, and it's not on this list. It's a newer one out this year. So this is will be updated here before too long. Trinity, these products. But if you go through and look at these materials, lots of 3s, 7s, and 11s, right? Like you go down this list, there's a 2, and it's a 2+. It'll work, but under moderate conditions, not under real high pressure conditions. The things that are the 4+ are the 3s and the 7s, and the 7s and 11s, and the 3s and 11s, right? So, and the same thing with spring dead spot control. You go up to the diseases. You can go down to spring dead spot, get your background in terms of development factors. That 65-degree range. We've got a couple of pathogens that are present for spring dead spot, particularly in Tennessee. We tend to have Ophiosphaerella cori and Ophiosphaerella herpatrica. We kind of have a mix of those two. Cori tends to be kind of a concentrated, kind of a dense, smaller spot, and herpatrica tends to be more of the open, larger spots as kind of a general rule. Fertility sources can make a difference. There's been some looking at that. If we look at the fungicides that are going to work well, Kabuto has been a gold standard for us, along with Tekken, 7 and 3, 7, Maxtima, another excellent DMI, 4+, 3, Navicon, which is partnered up with pyraclostrobin, so you got a 3 and 11. Again, same thing, right? Posterity Forte, you got a 3, 7, and 11 comboed up. Posterity XT. These are all really good products for spring dead spot control. We've seen excellent control in our trials, but we're still dealing with this 3, 7, and 11, right? And that's the challenge with that situation. And then this is that PPA1. And this is a document that comes out every year, has all of your active ingredients. You can kind of go down the list and look at all these materials that are available, combos and all of that kind of stuff. And then you can go to the various diseases in here. And if we go to something like spring dead spot, or let's go to a large patch, which should be right here. So there's large patch, give you a little, a little description of the disease development. And then you get in here to the fungicides. We're looking for 3s and 4s here. That's good control consistently across trials. So this is looking at it from more of a like location by location information and how often that fungicide performs well in those situations. And so if we're looking at those 3s and 4s, again, we're looking at 7s and 11s pretty consistently with large patch, not surprisingly. And we can see some of these materials that perform pretty well across locations are in those groups. And that's going to be typical of what we see. That's one of the reasons why for a lot of these, we see a lot of L's, which just means low data. And that's because some of this stuff isn't published in a public format. So they give it the efficacy rating of L, which is why I think particularly for the Southeast, some of the information that's contained in the Turf File site. And then hopefully with some of the work that we're doing with, expanding some of the stuff that we're doing with your app will be something to keep an eye on in the coming years. Cause I think we're going to be able to have some of that information in the turf weed manual app that I think will be exciting.
That's a good segue. If you can, let me share my screen real quick. I know we got to wrap up here. Brandon mentioned we relaunched this year a new version of mobile weed manual. So several of you have used this before. It is now available in the App Store as well as Google Play. The old web address still works and it will function as a web-based app if you want to use it that way. But it's a completely new user interface, incorporated photos. It's much improved from where it was. It was launched in 2011 and definitely due for an upgrade. And as Brandon mentioned, we're in the process of expanding this hopefully to be kind of a mobile pest management manual that would encompass weeds, diseases, and who knows, maybe even insects too, if we have enough resources to do that. So definitely check it out. And there's going to be more to come in terms of, we won't have an 11-year gap between versions. That much I can say for sure. Question here really quick. Any word on the EPA review of oxadiazone? It is in process right now. There was a letter submitted recently signed by myself and 18 other turfgrass weed scientists across the Southeast, or actually across the nation, I should say, about oxadiazone's importance and why it is so needed as a diverse mode of action and an important tool for some key weeds. So as turfgrass managers, I could say that your voice has been heard. Your university stakeholders have spoken up and communicated how strongly we feel about oxadiazone as a need for the industry. To the EPA, I know the registrants are going to be doing the same as well. So you can expect them to also have a loud voice in this as well, and we'll see. I think it will stay. Well, I should say, my hope is that it will stay. We may look different from a use standpoint, but just kind of be prepared. I know with talking to several about early order this year, there's already going to be supply chain issues that affect our industry beyond pesticides. And it's just something that keep in mind, knowing that there's increased scrutiny on oxadiazone moving forward.
Yeah, same thing with tridimethon. I just got an update. That's a Balaton. I got a request for a letter for that product. It's an older DMI, typically used for fairy ring and dollar spot, but it's a useful DMI in that regard, and we do have a lot of other ones. So if we were to lose the registration on that, it wouldn't be the end of the world. But that's another one to be aware of if you're out there in the turf world. Tridimethon is one that's kind of on in the re-registration process as well.
This is our GCSAA certification code for those superintendents that are with us that need this event approval code right here. So make sure that you mark this down. If you miss it, you can email me. I can send this to you. If you are watching this as a recorded session on YouTube, make sure that you list the actual event date of October 5th and not whatever day that you watch the video when you submit this to GCSAA. For those of you listening, this is not related to pesticide points or credits or certification in any way. What you see on the screen right now is only for golf course superintendents to receive continuing education for their certifications from the Golf Course Superintendents Association of America. With that, let me unshare. If you can't tell from the conversation, we're 8 minutes over our time, but certainly these topics, kind of shoulder season pest issues, whether it's POA or diseases, we work a lot on, we're real passionate about. If you need more information on anything discussed today, whether it's POA or large patch or spring dead spot, please feel free to reach out to the University of Tennessee. We're here to help you as you kind of do your best to manage these kind of shoulder season foes and get started and position yourself for a good 2022. So with that, I'm gonna leave it here. Thanks to all of you for listening. As I mentioned in the beginning, we'll be back in 2022 with more Turf Tuesdays. If you have anything that you want to have included as a topic or a potential speaker or a delivery mechanism for this content, please let us know. We're always in the place of trying to make things improve for the next season. So reach out, and with that, I hope you enjoy the rest of your year, and we will see you in 2022. Bye-bye.